Hi everybody, I hope this video finds you well. In today's video, we're going to be taking a look at another example of the chi-squared test for independence and homogeneity. Before we jump into this example though, I'd like to give a little bit of background about where this data has been adapted from. This data is adapted from a very famous psychological study called the Good Samaritan study. So I'd like to talk a little bit about that and sort of how that study was set up and actually run in real life, and then we'll talk about how we're sort of taking an adapted version of that data for our example. So the Good Samaritan study was done in the late 1970s at Princeton University, and its goal was to basically study what sort of factors played into people's decision to help others. Now, it's a pretty well-known fact that there's a concept called like diffusion of responsibility, which is that if you're in sort of a crisis situation around a lot of other people, generally speaking, people assume that others will take sort of responsibility and will handle or help in whatever needs to be done. So the Good Samaritan study was trying to isolate what happens, what are the sort of factors when only a single person is sort of in a situation to help another person. So in other words, sort of removing that diffusion of responsibility. And what they really wanted to study in this Good Samaritan study was how people's sort of stress level impacts their willingness to help others. So what they did is Princeton University and the researchers invited a large amount of graduate students in theology to the university on the pretense of giving a talk or a presentation as part of like a conference. And this was considered a pretty important sort of thing, and it was quite an honor to be selected. When the graduate students arrived on the campus, they were directed to one building on one side of the campus where they were told that's where they were going to hold their presentation or hold their talk. When they arrived at that building, they were then informed that actually something had sort of gone wrong with the communication, but their presentation was going to be held across the campus. So this sort of set up that these graduate students, these subjects, would need to basically make their way across the campus in order to actually give their presentation. The next thing, which actually sort of was the treatments in this study, was that some of the graduate students were informed that their talk was just about to start. In other words, they would have to hurry across the campus, and even then they might be late. Some of the students were told that their talk was going to start very soon, but if they hurried, they should be able to make it in time. And some of them were told that while they would, have to go across the entire campus, the talk wasn't scheduled to happen for another 30 minutes or so they had time to make it across. So in other words, the researchers sort of subjected the different graduate students to different levels of stress. Some of them thought that they had to hurry to make their presentation. Some of them thought that they had to hurry, but they had some leeway. And some of them thought that they had plenty of time to make it across the campus. The next thing that sort of happened in this study was that they were given a sort of map or a way of getting across the campus. And what this allowed the researchers to do is make sure that these subjects went through one particular area on campus. And in that one particular area on campus, they had made sure that there would be no other people around. So they had sort of blocked off a little section of the campus to direct these people through. In that little area, then, each of the subjects encountered an actor who basically pretended to be in some sort of distress, having some sort of like attack or seizure or something like that. And then what the researchers did is that they actually studied how did the different graduate students react. Now, they did a little bit more complex of analysis than we're going to be doing. They actually, I believe, had a 5 or 6 level scale for how people responded, but we're going to boil it down into a couple main categories. The best thing that a subject could have done was that they sort of stayed and helped. In other words, they stayed with this actor who they thought was in some sort of distress and stayed with them until help arrived and made sure that they were okay. The second sort of less direct approach was that they stopped to help. They basically checked in with the person, saw what was going on, but then continued onward. They didn't bother staying until more help arrived or anything like that. In other words, they stopped, but then they continued on their way. And then the sort of third and final group is that they did nothing, right? And in other words, that they saw this person was in distress and they just went about their business getting on to their presentation. So this was an actual study done, and our data, while not identical to the data that they had, is adapted from that original data. And I tried to keep it relatively close here so that we can sort of see how you would perform the analyses that we're learning in this class to an authentic sort of data set. So now that you guys sort of know the background, we'll actually take a look at this example here. So we're going to, again, suppose that our big sort of idea here is we're studying how stress impacts the willingness to help others. So to do this, you were gathering this random sample of adult subjects. Remember, in the real example, they were not specifically just adult subjects, but they were actually graduate students. They were actually graduate students in theology. Interestingly enough, as sort of a side topic, some of the students had been asked to prepare a presentation just sort of in general about theology, where some of them had actually been asked specifically about the parable of the Good Samaritan. So in other words, they had actually been preparing a presentation about helping others, and that was another factor that the researchers studied in terms of whether or not that actually impacted people's willingness to help. It turned out that it did not. So in other words, having prepared a lecture on the good behavior of helping others did not actually impact whether or not you would actually help others. But we're not going to worry about that part. So we're just going to say that you divide your adults into 3 groups. So you divide your subjects into 3 groups, and then we expose them either to low stress, medium stress, or high stress. So there's sort of 3 treatment groups here. Then we have each of our subjects encounter a distressed person, and we record their reaction as either sort of the best, which is that they stay and help, they stop to help, which is good, but they definitely continued on their way, or did nothing. And we get the following data here. And you'll notice, again, this is organized in our standard 2-way table. So we can see that there were, say, 16 individuals here who were under the low stress condition and stayed and helped. There were 5 individuals here that were under the high stress condition and stopped to help, etc. So what we're going to do is we're going to begin by carrying out at alpha equals 0.05 a hypothesis test to test the claim that stress or level of stress is related to willingness to help. So for part A here, this will be a chi-squared test for independence and homogeneity. How do we know that? Well, there's 2 different ways that you can identify that this is the correct hypothesis test to be using here. One of them is by simply just recognizing that this is a 2-way table, and that when we have data presented in a 2-way table, the most common hypothesis test is the test for independence and homogeneity. The other way to identify that this is the correct hypothesis test is to look at our claim here and notice that our claim is relating 2 categorical variables. Level of stress, which was a categorical variable with low, medium, or high, and willingness to help others, right? Stayed and helped, stopped to help, and did nothing. That's also categorical. So whenever you're looking at a relationship between categorical variables, chi-squared test for independence and homogeneity is going to be the right one. All right. Before we get into doing the test, remember we want to go ahead and augment this table with all the row and column totals. So let's go ahead and get those row totals first. So it looks like for the first row, you should get 55, then 2, 12, and 16 looks like 30, and then 4, 5, and 51, 60. And then in the column totals, we'd get 22, 18, 12, and 5. Looks like we get 35 there. And then 21, 16, and 51 looks like 88. And then summing up either those row totals or those column totals, either way, we should arrive at the same value. Looks like we had 145 subjects overall there. Okay, so there we go. That's going to always be sort of your first step to make sure you have all that before we jump too far in. All right, so now we are ready to go ahead and talk about our hypotheses. So for one of these chi-square tests for independence and homogeneity, remember that the null and alternate are sort of phrased as sentences, and they're always the same. The null is going to be that the 2 variables are not related. So stress is not related to willingness to help. And then, of course, the claim, what we're actually looking for evidence for, is that stress is related to willingness to help. So that's always going to be sort of the format for the hypotheses there. Null, baseline assumption, is that they will be not related. Alternate is that they will be related. Before we jump to the conditions, we need to do our sort of intermediate step here, which is that we need to construct the expected counts table. In other words, remember what the expected counts table is doing is saying, assuming that stress is not related to willingness to help, how should we have seen these subjects distributed amongst these different combinations of the variable? So we recreate our table here. So we have low stress, medium stress, high stress. And then we have, I guess we can abbreviate this as stayed, stopped, and nothing. Okay, so we got to refill that in there. Okay. Remember that the way you are going to fill in each of these values is by taking the corresponding row total times the column total divided by the table total. So to get this first upper left value, we're going to be taking its row total, 55, times the column total, 22, and then dividing by 145. So that first one should be 55 times 22 divided by 145. Looks like we should get 8.3 there. So we would have expected about 8.3 of the low stress subjects to stay and help. We actually had 16 of them do that. For the next one, for low stress and stopped, we'd be doing 55 times 35 divided by 145. Looks like we get 13.3 there. And then finally for the last one in the low stress, would be 55 times 88 divided by 145. And looks like we would get 33.4. So there we go. Now we'll go on to the next row. So now we would have 30 times 22 divided by 145. Looks like we should get 4.6 there. Then 30 times 35 divided by 145. Looks like we get 7.2. And then 30 times 88 divided by 145, 18.2. Then for the bottom row, we have 60 times 22 divided by 145. Looks like we get 9.1. Then 60 times 35 divided by 145, 14.5. And then finally 60 times 88 divided by 145. Looks like we get 36.4. So there we go. There is our expected counts table. We need to do that before checking the conditions because remember, condition 3 is actually going to reference this expected counts table. So let's go ahead and do our conditions here. Well, random and representative, well, that was stated in there, so we're all good there. The sample size being less than 5% of the population size. We're just using adult subjects here, so we'd say lots of adults. We'd be all good with that. And then for condition 3, we need to look at these expected counts. Remember, we want that less than 20% of the expected counts, smaller than 5. So we built 1, 2, 3, 4, 5, 6, 7, 8, 9 expected counts. Only one of them was less than 5. The medium stress and stayed gave us a 4.6. So we had one expected count out of 9 expected counts, less than 5. 1 divided by 9 gives us about 11.1%, which is less than 20%, so we are all good. So having one small expected count is totally okay in this situation because we built 9 different expected counts. Had there been another one less than 5, say maybe this guy here had been like 4.2, then this would have been 2 out of 9, and this condition would have failed. We would have had too many small expected counts. But in this case, since we had 9 different expected counts, having one be pretty small was totally okay. All right, now we're ready to go ahead and do our test statistic calculation. We'll go ahead and do that on our next page here. So for this, we're going to have to go ahead for 3 to do our test statistic. Actually, you know what? We probably want our actual data here. So we'll create a different page here. We'll get one where we actually have our data. All right. And so for step 3 here, we're doing our test statistic. Remember that our test statistic is that chi-squared, and it's going to be the sum of the observed counts minus the expected counts squared over the expected counts. Remember, this data up here, all this stuff here, these are your observed counts. We just figured out the expected counts here, so I'll bring these over as well, because we'll definitely want that. Okay, let's just copy that, and we'll put that over here. Okay, so there's our expected counts table. The data itself is always your observed counts, so we're ready to go ahead and start calculating here. Since we've got 9 entries in our table, there'll be 9 computations to do this. So chi-squared, first, we observed 16 here, expected 8.3. So it'd be 16 minus 8.3 squared over 8.3. Then we'd be adding to that. We observed 18, expected 13.3, so 18 minus 13.3 squared over 13.3, plus we observed 21, expected 33.4, so 21 minus 33.4 squared over 33.4. Then plus, now we're on to our next row. We observed 2 against an expectation of 4.6. So 2 minus 4.6 squared over 4.6. Plus, we observed 12 versus an expectation of 7.2. So 12 minus 7.2 squared divided by 7.2. Plus 16 versus an expectation of 18.2. So 16 minus 18.2 squared over 18.2. Plus, now bottom row, observed 4 versus an expectation of 9.1. So 4 minus 9.1 squared over 9.1. Plus, observed 5 versus an expectation of 14.5. So 5 minus 14.5 squared over 14.5. Plus, finally, observed 51 versus an expectation of 36.1 or 36.4. 51 minus 36.4 squared over 36.4. Now again, remember when you guys are doing this on your own, if you're comfortable with the formula, you don't need to write out the formula written with the numbers plugged in 9 times. Instead, what I'd really like to see is what we write next, which is what each of these actually comes out as. Because you can sort of think about these as the contributing components to the overall test statistic. So let's go ahead and do this. First one, 16 minus 8.3 squared, and then divided by 8.3. Looks like we should get 7.14 plus 18 minus 13.3 squared divided by 13.3, 1.66 plus 21 minus 33.4 squared divided by 33.4, looks like 4.60, plus 2 minus 4.6 squared divided by 4.6, looks like 1.47, plus 12 minus 7.2 squared divided by 7.2, 3.20, and then 16 minus 18.2 squared divided by 18.2, looks like 0.27, and then plus 4 minus 9.1 squared divided by 9.1, looks like 2.86, plus 5 minus 14.5 squared divided by 14.5, 6.22, and then finally 51 minus 36.4 squared divided by 36.4, looks like 5.86. So there we go. You might ask yourself, why do we bother having to write all those out? Well, the largest ones tell us if there is a relationship, where that relationship might be coming from. So we can see that the largest contributing test statistics here, right, are this guy right here with that 7.14 and something like the 6.22 and that 5.86. Those are all really large contributing factors. Where did those come from? Well, that came from us observing many more people under low stress staying and helping than we expected versus that 8.3, and also observing far fewer stopping to help versus that 14.5. and far more doing nothing under high stress than what we expected there. So that would sort of maybe tell us that it looks like, as we would probably expect, if there is a relationship, the low-stress individuals were more willing to stay and help, whereas high-stress individuals seemed unwilling to stop and help, and also unwilling and more willing to do nothing, right? Which is probably what we would have anticipated. But again, seeing these larger values tell us where that relationship might be coming from. And remember, overall, in a chi-square test for independence and homogeneity, it's just testing for a relationship in general. If this test is successful, if we reject HO, which we'll see in just a moment, it doesn't tell us what that relationship is. But looking back at the largest individual test statistics, sort of hint at where the relationship might be. The other thing I'd sort of like to point out to you guys, just so you sort of understand a little bit more about this formula here, notice that like the largest test statistic or contributing to test statistic actually came from here, where we had 16 minus that 8.3. And notice that that was actually a larger contributing thing than, say, this guy here, where we had 51 versus the 36.4. What I want to call your guys' attention to here is that 51 versus 36.4 is a bigger difference, but it doesn't contribute as much because of the larger expected count here. Whereas here, the 16 and the 8.3, it's only off by about 8, but that's relative to an expectation of 8. So what you got to sort of imagine, right, is think about like what would strike you as more unexpected. In this case, this is sort of like you expected 8 people to show up for a party, but you get 16. That's double the amount you expected. It's very noticeable, right? If you only planned for 8, getting 16 people to show up, well, that's a lot more. Here, this is where you expected about 36 people to show up, and 51 actually do. Now, of course, that's a lot more, but you expected 36, so you already expected a lot of people. 51 is certainly more than that, but it's not as big relative to your expectation. That's why this test statistic here is a larger 7.14 versus like that 5.86 there. Same thing with this guy being pretty large, right? 5 and 14 aren't that different, but this is saying that you expected like 15 people to show up, but only 5 did, right? That's very noticeable. So that's what this test statistic is really calculating. Let's go ahead and sum all this stuff up now that we had that little discussion there. And we can actually see that our chi-squared, 7.14 plus 1.66 plus 4.60 plus 1.47 plus 3.20 plus 0.27 and then plus 2.86 plus 6.22 plus 5.86. You should get a chi-squared here of 33.28. Now, chi-squared test statistics can be much larger than T and Z. When we were doing T and Z test statistics, we often got things like 2 or 3 or 4. If you got something like 33, you probably did something incorrectly. For chi-squared, that's definitely not the case. You can get very large test statistics here because remember, every one of these is going to be positive and they're added all together here. So we got our chi-squared there. Let's go ahead and get our p-value then. So we will need another page for this. So now we're ready to move on to step 4 here, our p-value. So remember that we want to go and use table D with our degrees of freedom being equal to, well, we had 3 options in this variable and 3 options in this variable. So that our degrees of freedom will be 3 minus 1 times 3 minus 1. Remember, number of rows minus 1 times number of columns minus 1. That's 2 times 2, which is 4. So we have 4 degrees of freedom, and we have our test statistic being this 33.28. So let's go ahead and take a look at table D here. So we've got our 4 degrees of freedom, 33.28. Well, it seems like we would end up right over here. So we'd be off our table on the right-hand side. Now, these p-values are getting smaller and smaller, right? 0.25, 0.20, 0.15, so on. So we know that ours is going to be smaller than the smallest p-value. So our p-value is going to be less than 0.0005. So we can say here that our p-value is going to be smaller than 0.0005. Then we can make our conclusion. If we take our p-value and we compare it against the alpha of 0.05. Obviously, the p-value here is very small, so it is certainly smaller than 0.05. So we will be rejecting HO. If we just pop back, what was our HO? Well, our HO here was that they were not related, so we're striking that guy out, and we are finding evidence that stress is related to willingness to help. So we would say significant evidence that stress is related to willingness to help. Now, do we know exactly what that relationship is? Not according to this chi-squared test for independence and homogeneity. It just tells us that there is a relationship. If you guys ever take a more advanced stats class, well, you can learn what is called sort of post hoc analysis, which is sort of follow-up analysis, and it would go more in depth in identifying these largest contributing factors and saying, well, that's probably where that relationship is coming from, and would help us establish that low-stress individuals were more likely to stay and stop, whereas high-stress individuals were more likely to do nothing, and that would actually establish the relationship. But from the perspective of a chi-square test for independence and homogeneity, all we say is that there is evidence that the variables are related. All right, we wanted to do one quick follow-up. We want to actually take a look at building a confidence interval, I believe, for the percentage of adults under low stress that stayed and helped or stopped to help. In other words, we're basically doing a 95% confidence interval for the percentage of adults under low stress that did something. Now, you'll notice that we're only doing this for the people under low stress. In other words, we're not combining all the people together, low stress, medium stress, and high stress, because in part A, we figured out that these are related. So it's not really fair to lump the low stress, medium stress, and high stress people together, since apparently stress is an important factor here. So we're only going to be looking at the percentage of low stress individuals that stayed or stopped to help. So let's go ahead and do that. So for part B here, we want a 95% confidence interval for the percentage of low stress adults who stayed/stopped. Okay. Now, we are estimating here a single percentage. So this is going to be a one sample proportion confidence interval, because we're just trying to estimate a single percentage. If we were trying to estimate the difference in percentage, we'd use a two sample proportion confidence interval. But in this case, we just want a one sample proportion confidence interval. So let's talk about the conditions. Well, the first two are always the same for all our procedures. So we can say that those have already been checked. Good. For condition 3, this means that we have to have at least 10 successes and at least 10 failures. Now, we do have to be careful here. What counts as a success? Well, it's not just staying or just stopping. It's staying or stopping. So if we go back here, right, what counts as a success? Well, only for the low stress people. So we'd say that and that. Those count as successes, whereas the low stress people who did nothing, those count as failures. So our successes here, and just to color coordinate here, our successes would be the 16 plus the 18, because we don't care if they stopped or if they stayed. That would be 34 successes, which is greater than or equal to 10, so we're all good there. And the failures here would be all the low stress individuals who did nothing, which would be at 21. Notice that the medium stress and high stress data is completely ignored here because we're only looking at the percentage of the low stress subjects. So our failures here would be 21, which is greater than or equal to 10. Check. Notice you can also note here that this means N. Well, we're not using all the subjects. We're just using the ones that were low stress. There is 34 and that 21. That means that the N here is going to be 55. And again, notice that that would correspond back to when we did the row total for the low stress individuals was 55. It's not going to be 145 anymore because we're just looking at the low stress group. Okay, so we have all that. Let's go ahead then and do our construction. So for our construction, we're going to have p hat plus or minus z star square root p hat 1 minus p hat over n. And we're going to need three things, p hat, n, and z star. To get the p hat, we're going to take our successes, 34, and divide by our sample size, 55. So 34 divided by 55. And 34 divided by 55 is going to give us approximately, looks like 0.618. So about 61.8% of the low stress subjects stop to help. N is 55, and that Z star, well, we're going to be using table C. Z star, 95%, but we've done this many times now. It's going to be at 1.960. So we'll throw that in. 0.618 plus or minus 1.960, square root 0.618, 1 minus 0.618, all divided by 55. Let's go ahead and get that margin of error. 1.960 times the square root, 0.618 times parentheses 1 minus 0.618, divided by 55. And looks like we get 0.618 plus or minus 0.128 as our margin of error. Then if we do our subtraction, 0.618 minus 0.128, looks like we get 0.49. And when we do our addition, looks like we get 0.746. So we would say that we're 95% confident that between 49% and 74.6% of low stress adults will stay/stop to help. So in other words, we're basically saying that according to this data, if we have an individual who's under a low stress situation, there's somewhere between a 49% chance to a 74.6% chance that they will do something to help this distressed individual. They'll either stay to help or stop and help for at least a little while. So, if you guys are curious, the data that we're using here is adapted from a real psychological study, which basically, to sort of summarize what they found that for low-stress individuals, they did have a very similar result here. It was about 60% of them did something to help. For medium stress, it came out to about 45%, and for low stress, it was as low as 10% only were willing to help in some fashion. So this was pretty conclusive evidence that people's sort of stress around them impacted their desire to take time to help another person. Now, like we said, this is only one factor, right? There's other factors like diffusion of responsibility, but as you can sort of see here, the idea of this study was to isolate down to one single factor, which in this case was stress, and analyze how it was related. That doesn't mean stress is the only determination in terms of whether or not somebody's willing to help, but it helped us understand this relationship. In our next video, we'll be going on and learning another chi-squared hypothesis test called the goodness of fit test.